Sometimes we need to be able to switch back and forth between rational exponents, an exponent that looks like a fraction, and radical symbols. In the next two examples, we're going to go back and forth between these two forms. For example 11, letter A, we're given 9 to the 5/2 power. When you're working with rational exponents, the number that's in the denominator is the index of the radical symbol, and the number that's in the numerator ends up staying as an exponent. We have a couple of options here for number 11, for A. We can write this, we can write this as 9, to the 5th power, and then the index of 2 means it's a square root. That's one option. Or we can write it as the square root of 9 raised to the 5th power. Looking at the first way that we wrote this, we could probably simplify this a little bit. We know that if we take 9 to the 4th and then 9, we could simplify this to be 9 squared times the square root of 9, or 81 times the square root of 9. But the main point for this is just to think about those two different options that I wrote here and here. Notice that the exponent stays the same as a 5, that upper number, and then the square root comes from this 2 in the denominator. Moving on to example B, I can either write this as x squared and then the cube root. The exponent comes from the 2 and the index comes from the 3. Or the cube root of x and then that whole thing squared. So this is how to take things that have rational exponents and rewrite them as radicals. Let's go the opposite way now for number 12. Looking at example A, I've got a square root and then I've got 5y raised to the 9th power. So the way that I can write that is the x that's on the outside is just going to stay by itself, but I've got 5y, the exponent is a 9, and the index is a 2. And I've got to put the 5y in parentheses because the 9/2 exponent goes to both the 5 and the y. For example B, I have 64y, and the whole thing is raised to the 1/3 power. For example 13, we're now going to simplify, in this case, products that have rational exponents. Rewriting example A, I can rewrite this as the 4th root of z, and then that's being multiplied by 3 times the 4th root of z cubed. I want to combine these two together. They have the same index, so I can take the items that are under the radical and multiply them together. So then I would have that 3 is just kind of out on the outside. I can take z and z cubed and multiply them together under that 4th root. Well, that's nice because now I've got z to the 4th power, and I'm taking the 4th root of it, so that'll just be 3 times z. Let's go back and do this problem a second time using things that we learned before about exponents. If I think about this problem as, let's see, z to the 1/4 times 3 and z to the 3/4, I've got two items that the bases match. And our rule for exponents says that when the bases match, you can add the exponents together. So this would be the same as, I'll put the 3 out in the front, z to the 1/4 plus 3/4. I can add those exponents since the bases are the same. 1/4 plus 3/4 is just 1. So I end up getting the same answer if I do it this way as well. Let's look at example B. I've got 1/3 and it's acting on both the 8 and the x. So let's tackle that part first. 8x to the 1/3 is the same as the cube root of 8x. The cube root of 8 is 2, so it looks like I've got 2 times the cube root of x. Looking at the second term, that 14x to the 6/5, the 6/5 only belongs to the x and not to the 14. So that 14 is kind of going to be on its own. Let's combine together what I've got. I'm going to take this and combine it with this. I've got 2 times the cube root of x times 14 times x to the 6th power and then a 5th root here. I'm going to multiply the 2 and the 14 together to give us 28. And then I've still got a cube root of x and the 5th root of x to the 6th power. Looking at this guy here, this would be, I've got 5 plus 1 x's. So maybe one of them could be taken out of that radical symbol. So let's see, what are we left with here? I still have this sitting here, and I've got this now. So I think I've got, going over here now, 28, and I've got an x. I've got a cube root of x, and I've got a 5th root of x. I don't love how this is. This looks a little bit wonky, doesn't it? Maybe we want to see if we can simplify that. The cube root of x is x to the 1/3 power. And the 5th root of x is x to the 1/5 power, the 5th root of x, yeah. If we use the idea we did in example A where we add the exponents, what's 1/3 plus 1/5? I need to make the denominators the same. So I've got 5 over 15 plus 3 over 15, which is 8 over 15. Kind of a crazy answer, but let me move this over a little bit. I think what we're going to end up with is 28x, and then we're going to have another x to the 8 over 15th power, or 28x. I'm going to put 15 as the index, and then we have x to the 8th power under the radical sign.